Hi, and welcome to the SASE 101 for security practitioners as part of Netscope's SASE Week. My name is Mike Ferguson. I'm a cloud security professional working at Netscope. I'm going to run you through a few pointers I think that's kind of relevant as we try to learn a bit more about SASE and what that is. So first things first, what is SASE, or Secure Access Service Edge? This is an interesting new acronym that has come up. So I think the best way to get started is to just look at where this came from. So Secure Access Service Edge, or SASE, whether you like the acronym or not, was defined by Gartner. It's an emerging framework for convergence of networking and network security services within a global cloud-based platform. Very grand. Okay, well, let's just try to go back a bit and understand what that means and why that's come around. So let's start with, why did SASE happen? How do we get to this point? Well, if we go back 50 so years to when businesses started to move away from putting pen to paper and started to digitalize their information, we started with computers, and we would create new word processing documents of our information. And then in order to share that information, we needed to centralize this stuff. So we built centralized storage components, file servers, and then we would have databases with our employee or customer information on there. And we'd then have applications and application servers that were also centralized so that we could have applications that could process this information, this intellectual property, and send it out to those customers and employees using that database. And that became really critical, ensuring the availability of that those services and the integrity of those services and the confidentiality of that data became critical to the success of a business. So we then built these things called networks and these frameworks around security to ensure that the services were always available, and our information was protected, and we were able to continue operating and generating money and doing all the good stuff to ensure our business succeeded. But the landscape's changed, and now we moved a lot of that infrastructure out to third parties. It started with IT departments going, okay, well, maybe if I have a file server that's hosted in a third-party environment, I can have my own little space of this, and but I don't have to worry about updating that, refreshing the hardware. I just pay a premium, a little service fee to keep that information available. And then our file servers became cloud storage, our email gateways became webmail, databases became collaboration tools. But it wasn't long before the entire business was like, "Ooh, wow, I would like to do this as well." And our marketing departments got hold of MailChimp, SurveyMonkey, Marketo. Finance got Concur and Expensify. HR got SAP and a bunch of other SAP and a bunch of others. And suddenly there was just more choice out there than ever before. And our businesses were operating inside of these different environments, and it became incredibly complex, and there was lots of choice, and we were using lots of these different things. And one of the big problems with that is that now our data's moved out of the network. So our critical business services are outside the network, and our data's moved out of the network. And now we also know that a lot of our users are working outside of the old network. So we need a new method, a new mechanism to ensure that the connectivity of our users to those services is continued and is always available, and we're not losing access to that information, so we can continue to make our businesses effective and competitive in your own marketplaces. And whilst yes, COVID has increased this, it was definitely on the way already, but the cat is out the bag, the bull is out the pen, and we need a new approach, a new mechanism, a new way of thinking, or a modern solution to this modern problem, to try to ensure that we can maintain high availability, integrity, and confidentiality in this new world. So why is SASE important, other than that point we made? We're undergoing this huge network inversion. We know that the networks are evolving. The amount of remote workers has more than doubled from last year. I imagine it's more than tripled, to be honest, with the way that COVID has caused our users to be working from home. But this wasn't something that was caused by COVID. This was happening already. I think COVID just accelerated the inevitable. We also know that cloud applications and services have overtaken the web traffic or websites. It's over 50% now. And because it's cloud applications, that information is also encrypted. So we can't even see, a lot of the time we can't even see inside that traffic. And when we do, the language is actually different as well. So it's no longer just GET requests and HTTPS traffic packets. There's API calls and JSON strings that are part of that communication between the user and the cloud application. So we have to think about it differently. We have to move away from what we originally built as a site-centric model or data center-centric model, where we built a network, put our information inside of there, put our applications inside of there, and then our network services like route selection, bandwidth aggregation, WAN optimization, MPLS, all those different things we built to do our network availability, that has to change. That's gone as well. And all then the security services we put in place inside that network. Then our users would then connect to that network, and they would be given access to all those different those pieces of information, but all those services, because it was the users that were connecting into the network. So we could control the network and the data center. But now, because there is very limited network access, our users are just connecting to those services, whether they're SaaS or IaaS or private applications. The users are connecting to them from home or wherever they are located. So it's up to us to then move to this user or data-centric model, where we are applying the security controls to the users and the data as they're accessing those multiple highly distributed set of services across the globe. So we have to think about it as no longer just this data-centric, we have to move to a data-centric model. And this is kind of interesting. We can see that this is happening just by looking at the amount of growth on the internet, just the amount of traffic that is, amount of internet traffic that is being used and consumed, whether it's in different regions or across the globe. Like the worldwide growth in 2020, we can see that we are using the internet not just to access websites, but to access our corporate data. So, up to 5,000 terabytes per second of data. So we could just say that it doesn't matter about the region, the amplification, the acceleration of leveraging the internet is being consumed, much more rapidly. So a typical approach is to trying to connect our users to those services across the internet just aren't equipped to achieve this. We could use things like a public cloud, AWS and Azure, but the problem with these things is they are limited to many regions, and a lot of the time they're mostly architected for cost and availability as opposed to performance. And a lot of those environments also have their own products, their own internal offerings, so they're able to ensure that their internal offerings get the faster controls. And then, of course, they're going to compete with one another and play funny little games to ensure that they get the better peering relationships, which you end up finding you've got inconsistent performances. And then you're going to get different behaviors because you're in different locations. So if you're in one geographical location, you might get only a few number of hops to get to your destination application or wherever that's located. Versus if you're in a more remote location, your user's on holiday, and they then also need to connect to that application, they're going to take a larger number of hops to get to that public cloud offering. So you're actually getting a much more inconsistent performance, which is not what we need in this age. So we could also then turn to transit providers or ISPs. But we all know that this is heavily commoditized, cost optimized, there's no real performance capacity or utilization awareness, and it's much more of a ticking the box, and we don't move away from any of those multiple hop issues to get to our business services. So traditional approaches just can't achieve the high availability and connectivity requirements that we need today. Another reason it's important is the language has changed. So we all know that when we go into one of our applications, they are delivering a business service. Storing of files is no longer about uploading a file and downloading a file. I might want to edit it, I might want to create it, I might want to delete it. There's things I do inside these applications. If I'm using marketing campaigns, I might want to reject or approve a marketing campaign inside of Marketo. So we know that there's additional things happening inside of here. We're going above and beyond those traditional HTTPS packets. So we're not just looking at the GET request, but there's a lot of other things inside of there that a traditional web proxy or firewall is going to be missing. And we know that the language is APIs and JSON strings, and there's a bunch of interesting information, contextual information going on behind the curtain that we can leverage to say, okay, I want to know what's happening. And that's important to apply the right controls for the right users as the right access the right applications and the right information. And there are literally tens of thousands of these applications. It's that context that's hyper important. Is this application risky? Who is sharing it? Why are they sharing it to? Who are they sharing it to? And is the application of data the higher risk to my organization? And it's understanding that context. That's why it's important. So why does SASE matter to you? I think the important parts to think about the different teams within an organization. Let's start with the networking team. Why does this matter to the networking teams? Well, networking teams are historically about connecting your users to each other and to their business services and the data. And now we know that, not only is my internet pipe connecting me to these public applications that are highly distributed. We have about, on average, about 1,500 different SaaS applications being accessed every week by organizations. We also need to connect to private applications that might still sit inside of my legacy data center or within my new infrastructure as a service. But then also my workforce is highly distributed. So the problems of connecting those users and navigating through some of those traps and risks has become increasingly difficult. And those services, as they're highly distributed in a theoretical sense, physically as well, they may well be highly distributed. Your workforce is also highly distributed in certain different locations. So any SASE cloud needs to have a huge global footprint, which allows them to your users to connect to them in as quicker fashion as possible without going through those public internet hops. It's almost more important that you have more locations than it is actual data centers, because it's those locations that are allowing your global workforce to connect to the SASE network as quickly as possible based on the geographical locations. So having a huge global footprint becomes really, really powerful and important. And a good thing to note is that the SASE should be have a consistent compute and enforcement capacity and capability across all of those data centers. Avoid the things like the virtual POP, where yes, you connect to a virtual part of the SASE network, but if you want to actually get the DLP or the sandboxing capability or some other element, then you'd have to go off to another data center and then return back and then go off to your managed the actual application that you were looking for. All of that compute power has to be delivered inside of those global data centers consistently to ensure that the performance and actually the return time, the lower latency, the high performance, the better throughput, the better return time is delivered to your workforce wherever they are located. And if they are globally distributed, then it's important to be peered with any of the global ISPs. And I think that allows your workforce, wherever they are located, they connect to the ISPs. So say you're in the Cook Islands, your marketing manager is in the Cook Islands, he's on holiday when we could travel, and he connects to the local ISP. There's a peering relationship with the ISP to the SASE network. So the packet is directly handed over to the SASE network, and then through that global network, the SASE can hand over that packet to the application, the managed services, data center or application directly as well through their peering relationships. So it's very important to find a SASE network that it has those highest number of peering relationships, because that's going to ensure that you're not then having to rely on those public cloud infrastructures that aren't built for performance necessarily, or going over those ISPs and the public internet. So why does that matter to the security teams? Well, hopefully with that faster return time that we've gotten from the global SASE network, we actually get a bit of a performance budget to spend on security. And if all of our traffic is now being used through the internet to those applications, then I need to maybe move away from having I can move away from having all of these different siloed capabilities, these siloed different boxes that cause a lot of complexity. Legacy appliances, we know if you've got a secured gateway that has to do SSL, that hardware needs refreshing. Even if you go to virtual appliances, you've got to spin up new VMs. SSL inspection is resource hungry, so we need to then increase the number of boxes. Then if you wanted to apply DLP, well, that might need another management console as well as another DLP appliance. So we've got more and more boxes. You've got two different consoles. We're going to have two different teams. VPN is separate as well, the VPN concentrators, and more boxes. They're going to have to be spin up, and we're going to have different management consoles to see what's happening here. So you've got different teams looking at different things. It's all inline traffic. What we're ending up with is an incredibly complex and hard to manage security suite. And it becomes increasingly important to say, well, if my traffic is going through this internet pipe, maybe the SASE should be able to deliver on all of those that security stack consistently to reduce that footprint. The other point is a lot of this stuff is built for a different world. It doesn't understand the language that we talked about with the cloud. So talking about complexity now, because we know that we're using that internet pipe to connect to a lot of cloud applications, the SASE should be cloud application aware. It should have the strong understanding of the cloud application world, and allow you to have inline controls to say, hey, Mr. User that's uploading their data to the riskier applications, did you know that there is an alternative available? You don't have to leverage, you don't have to look at all of those high-risk applications. We know that you should avoid the magazines on the top shelf and just go straight to the Rolling Stones magazine, because that's the sanctioned magazine for this company. Or OneDrive is the sanctioned application for this organization. Google Drive is sanctioned. And we can provide consistent, constant inline cloud security education and coaching, or guardrails, to our workforce, because we understand that cloud world out there, and it gives you, some the approach that's required. We also know that using the cloud applications, we don't just use it by browsers. We have sync clients, we have native applications, command line interfaces. There's a whole variety of different approaches that we can use. And one of the biggest problems with data is it does seem to find a way to get out there. If you also start to synchronize and connect up multiple different applications, you upload a file to Slack, it's going to save it into Google Drive because one of your users approved that. Data just finds a way of getting out there. So it's important to have a SASE platform that can allow your data all to be steered to this centralized point, and then understand what that data is, where it's going, what the application is, and the context of what's happening there. Because we know that controlling data and using legacy tools, things may well get missed. SASE also allows that you could have a zero trust architecture. We're seeing a lot of information inside of here, so it becomes important to have a constant and continuous evaluation throughout the session. I can see who the data is. I trust the identity from my identity provider. I can see the application usage, the devices being used, the common behaviors. Are they uploading in bulk? Are they exfiltrating data to a non-sanctioned application? What location are they in? And using a risk engine inside of here, I can leverage policies based on that risk to say, yes, that user is using a sanctioned application on a sanctioned device, or a low-risk application. They're coming from the right location. This is something that should be permitted. Or maybe those applications aren't correct. The location isn't accurate. Maybe the identity isn't trusted because it has been, maybe we should prompt for multi-factor authentication prompts again to see if we really do trust that this user is who they are, and use an inline policy enforcement constantly to reevaluate the risk profiles of the user and the activities that's being used. So we've got some ideas of why a SASE might be important. Let's look at some of the consequences of living without SASE. So imagine if you've got a cloud storage application, you've gone with, say, Google Drive, your users are uploading it to it. That makes sense to us. The problem is that you're not alone in that. We know that you're going to have partners that have also gone and signed up to Google Drive, and they're going to send you a shared folder. Your users may also have a Gmail account, I imagine, and therefore they're going to have a personal Google Drive. But this could be OneDrive, Dropbox, Box. We're all using those same applications, and that becomes interesting when we start to talk about, well, I have sensitive data, and where should that data be allowed to go to? If I've got tax file numbers or social security numbers or national insurance numbers, do I want that information to go be uploaded to my, in a HR store within the corporate Google Drive? Well, probably yes. But the same Google Drive is drive.google.com and personal. Should that data be going to those different instances of the same application? And if you're living still with a legacy secure web gateway, that URL is deemed as Google Drive perhaps, but it can't differentiate whether or not certain data should be going to those certain different types. So you're missing that interesting part that we talked about within the inline communication, those APIs and JSON strings, to determine, is the API telling me that the application may well be Box or Google Drive, but that's a personal instance, and therefore the activity isn't allowed of uploading passwords. To the corporate instance, absolutely go for it, it's not a problem. But the ability to understand the API calls inside of there allows us to make those decisions that the legacy web proxy wouldn't. And going back to that, that's not just about data movement. There's still things that we're doing inside of here. Like if you've got new interns, you might say, well, I might want to allow my interns or my junior members to log into my corporate network, my corporate Google Drive, and upload and edit and create content. But do I trust them to delete content, move content, rename content, and share it with the wrong people? Perhaps not. But would I trust them to do it in their personal one? Of course, it's their personal instance. And having the ability to differentiate between the different instances and then the activities allows you to protect your resources in your corporate one, whilst allowing them to get on with their own personal stuff when they're working from home or wherever. And then again, that's those JSON strings inside of there allow me to understand what the activities are inside of that traffic, and again, apply the right controls that matter to your organization. And this goes on to public cloud as well. So if you've got any public cloud infrastructure, you're going to have production instances, development instances, even customer-facing instances of those services. It's an entire network dedicated customer-facing. You put a web server in there, and your customers log in and do their thing. Now, a developer may want to reboot, shut down, restart a server or a database inside of the development instance, and they should be allowed to do that. But if they accidentally log into aws.amazon.com or connect to the wrong command line interface, they then run this string to reboot that server, then we need to ensure that that activity doesn't happen. So understanding the instances and activities combined allows you to really protect your infrastructure and your reputation of your organization with the right controls that you're after. Now let's look at when your users are working remotely and they are connecting into your network. So traditionally, we know that when a user wants to connect to the network, they spin up their VPN client, connects to the VPN concentrator, and okay, that gives you access to everything inside the network. Probably is a bit of a security risk. But now, say we moved some of our services up to my public cloud. So I've moved my Jira up to Azure, and I create a VPN concentrator. And when I need to connect to it, I spin up a second VPN client to connect to that network. and they need the Oracle database, I spin up a second VPN concentrator, and another one, and another one. The user experience is really complicated, and it's really tricky for them to understand what network they need to connect to in order to connect to which application. So most people don't do this, but that is a tricky approach. So instead, what most people do is go, okay, well, I'll have a single VPN client connect to a single VPN concentrator in my network, and then I'll connect out to all those different things. We call it hairpinning. And then the problem with this is that when your users are working remotely, maybe they're working abroad, maybe they're stuck abroad, they are then having to connect all the way back into the local data center, the corporate data center, corporate office, to then hairpin and go back out to those applications that could be in the other side of the globe over the dedicated links, perhaps, or out via the public internet. So the performance is really inconsistent immediately, and it's not the right, not a good approach to deliver on. But especially not now, because we know that most of our workforce has been having to work remotely, and they're all connecting back in via the single VPN concentrator. Most of these environments were architected to take about 30 to 40% of the workforce working from home 50% of the time, not 90 to 100% working from home 100% of the time. So these VPN concentrators are already struggling, and also still giving you access to everything inside the network. And their performance as they connect and hairpins is just becoming far, far too much. So we need to find a different approach to move away. This is a consequence of living without the SASE. Our networks are just not architected to deliver on it. So what should SASE deliver for you? So the best way is to converge the network. Let's make it consistent and reliable and persistent connectivity to all of our applications, make it very easy for the users. You should be able to point your users wherever they're located to a global cloud server, data center, so that they can get that constant connectivity. And it will connect you to your websites. It should be able to connect you to your cloud applications, and it should be able to connect you to your private applications, whether they're in public cloud or within the network. And it should be able to ensure that you only get access to the applications that you need access to. So the performance is increased because you're not all hairpinning back into the network to go out to, going up to this global a presence globally within the SASE cloud, and it is stitching together the access you require based on your controls to say that you can get access to all the different private apps, cloud apps, using those peering relationships as required. And because it's conversion, because we're all going through this single point, then we should be able to provide the converged security and give you complete visibility and control, whether it's going to your websites or cloud applications or private applications. I should be allowed to start applying access controls on who gets to access what activities, what instances, what type of data should be allowed to move up, what type of files should be allowed to be downloaded. Is it malware? Is it a save file? And then I should be allowed to apply intrusion prevention on risky plugins and different components inside of that traffic. I want to see risky behaviors using UABA. I want to isolate certain traffic if I think that there might be something riskier in an unknown website. I need to isolate that. And I also need to start looking at the lower level packets. I want to be able to provide sort of a cloud firewall approach. But the entire security stack now no longer sits inside the network. It needs to be delivered as a security as a service inside of that cloud as we move up to that. So what that starts to look like is the SASE unified security stack and policy set is along the bottom here, we've got all of our users connecting however they want to connect, whether it's clients, IPsec tunnels, SD-WANs, connect to the network, the SASE network. That new edge infrastructure should be this fast global infrastructure with all that peering and all that smart routing. And it should have an engine in there that allows you to give really strong context and understanding of the APIs and JSON strings as you're connecting to your web traffic, your cloud applications, your public cloud security, and your private applications to apply those different microservices on there. Adaptive access control. I want to see who's accessing what and they're accessing it. Should they be coached to use others? Should they be allowed to access and upload to certain instances? Should they be able to delete and move files in others? I want to apply the strong DLP capabilities. I want to provide threat protection and isolation, compliance checks. Should they be allowed to upload to PCI, DSS, non-compliant services? And it should also then have a single console to apply the management controls against all those different types of data, whether it is web traffic, cloud apps, or private applications. It shouldn't matter. We need a single console. I don't want to be able to have to teach my security engineers and operators to leverage different consoles, different reporting engines for those different components. It's all inline traffic, and that should be a single management console for that. And then once we see all that information, I need to then be able to integrate those with the third parties. So if I've seen a threat in my sandbox engine, then I need to be able to say, well, okay, I need to update my EDR to scan the threats on premise on those endpoints. And if I create logs, I need to integrate that with my SIEM solution or within my automation tools so that they can then provide responses back to my identity provider. I need to get identity information from my IDP, provide SSO into certain applications, or to provide multi-factor authentication prompts to when certain activities are being taken place. It's all part of that new ecosystem, and those integration points become very, very powerful. Because we're seeing so much information in here, there's one of the things we need to do is then go and move away from having reporting to actual analytics into that activity. It's no longer just about information. I need the so what's. I need the insights into what's happening here. That means it's no longer about data, it's about relationships. So instead of saying, well, we have 10 DLP policy violations a month, okay, well, what does that mean? I need to see trending information. I need to see the relationships between month and month. I want to see if we've reduced uploads to risky applications by 20% on this month. What was it last month? And I want to see the worst offenders and how they're behaving compared to last month, etc. So trending information over time becomes super powerful, and seeing those relationships. So advanced analytics, SASE dashboards, things that can tell you total threats defended, adoption metrics. Are users' behaviors improving? Do I need to provide additional coaching in other areas to ensure that my security program is constantly provided with the right information so that I can pivot to where is needed as required? Because I'm seeing all that information, it's important that we can then provide some analytics on top of that. And some context around, like, okay, well, I'm using, these are the applications, but what are the different instances that are being uploaded to? I can see multiple different instances for Box, whereas most people are only using the corporate one for OneDrive for Business. Having the ability to see those different instances and then understand where my data might be flowing to becomes really powerful. So it's a lot of stuff in there, and I think it can seem a little overwhelming, but it is easy to get started with SASE. The best way to look at it is that whilst there's this platform of services, there's microservices being delivered within that cloud security platform, SASE, it's still siloed into, it can still be siloed into traditional security market areas. So, we do still have secure web gateways, but the secure web gateway has to evolve to understand your SaaS and websites as well. So having the instance awareness and activity controls is really important. CASB, security broker, so I need to be able to scan my data at rest and look after unmanaged devices, whilst also providing that DLP to those applications. The cloud security posture management, so I can ensure that the compliance checks are being applied to my infrastructure as a service resources continuously and maintaining them, and then also having the zero trust network access or remote access services allows me to connect to my private applications in line through the same SASE network. So yes, whilst the SASE platform is a single entity that should be delivering your users to your applications, we know that you'll have an investment in other areas. So, but understand that you can still break them up into these traditional IT security market areas is available and is possible. And then when you're ready to go on that journey, you can then pick the one that's coming up next. Okay, well, maybe I've got a secure gateway renewal that's coming up. Well, maybe I want to replace that with the next gen secure gateway. And it's to make sure that I've got integrations with my identity provider, and it needs to have the ability to look at instances and activities. And then you can replace that. And now you're getting started. You've got the Netscope, the SASE client deployed and installed. So then, okay, well, maybe I want to look for a remote access service next. So I want to take away my traditional legacy VPN capabilities and leverage the client that's already installed. And you put in a zero trust network access tool in there as well. And because I'm seeing all this traffic in line now, my DLP capabilities and UEBA can be next with integrations with SIEM and your next gen endpoints as well. So it's this little legacy, this little journey that you can go on, taking you all the way up to a pure, an entirely cloud firewall solution with integrations with SD-WANs and everything. So it is that journey, but you can pick and choose as the requirements come up in whatever technology renewals you've got going at that particular time. And then once you've got even part of that SASE solution, you can start to look at your entire ecosystem, what that means to you. So what are the integration points? They should all be cloud-based, because that's, again, that doesn't take away the problem set of your users being remote. Really ensures that you do need to have something in the cloud. So having a cloud-based identity provider that can do SSO, multi-factor authentication, and authentication of your users as they're accessing those cloud applications becomes important. So having that integrating with your next-gen endpoint technology for threat intel exchange, maybe even some DLP capabilities becomes very important. And then having all of this fed in to your automation and orchestration so that it's continuously monitoring and detecting risky behaviors and then responding to hopefully prevent future incidents from occurring. So hopefully that gives you an idea as to what the SASE is, a 101 understanding of where SASE is going and why it's so important. I'll open it up to 20 questions. I'll just check. Okay, so we hear so much marketing buzz on SASE. How do we know what real SASE is and what's marketing? It is tricky. Like, I think if anytime there's a new Gartner buzzword, market seems to get flooded. I remember this with CASB. Everyone had a CASB as soon as there was a CASB. So we know that the market's going to get flooded with a lot of FUD and a lot of fluff. I guess if you can Google SASE and whoever's paying the most for the latest and greatest search engine optimization, going to get higher up the chain. I think the important part is knowing where, within that journey, where are you at? What tools need replacing at the moment? And then what are your requirements? Understand what you're looking to achieve, whether it's reducing the number of cloud applications being used, risky cloud applications, reducing the amount of sensitive data that could be being exposed, and then understanding what capabilities are out there. Educate yourself, go to the market, see what different tools have different capabilities, and then honestly, just get those vendors to prove it. I think that there's a lot of stuff going on in for the remainder of the SASE week. Take a look at some of those other sessions to learn about those capabilities, and then speak to the team and say, okay, well, put your money where your mouth is. I want to see if this can be delivered. That kind of stuff is really, really important. So yeah, there's going to be a lot of marketing buzz. There's always is with new terms, but ultimately, let's see if it works. So make it work. Okay, what key features of a SASE should we be looking to for protecting sensitive data? I've been doing DLP for a long time, and the hard part about DLP is reducing the number of alerts, because you don't want false positives and then having to go through this, because you get alert fatigue and just get sick of it. So having policies that really hone into the things you care about. Here in Australia, it's tax file numbers, it could be social security numbers, or national insurance numbers in the UK. Find that one thing that's really important that you protect, and then apply instance aware policies. So if it's uploading to corporate policies, at any amount, perfect. And then apply a threshold policy on if it's uploading to something that's non-corporate, and that reduces significantly the number of false positives, and hopefully will allow you to investigate that a little easier. Okay, so could you still use prox.pack files? You can. Prox.pack files are kind of an old school way of doing it though, and as I say, data flows like water. So a lot of these applications don't listen to things like prox.pack files. They just they're going to just go by the default gateway, and then they're going to be missed. And especially if it's using, there's legacy tools that primarily focus on prox.pack. They don't look at APIs and JSON strings. So I'd recommend going away from it because you're going to miss those native apps, sync clients, some of them, and they're just not going to see potentially that those APIs and JSON strings. I'll take one more. Okay, is SASE a product? Maybe in the future, I think that you may start to see it a little easier. But no, I'm sure that there are, if you speak to any vendor, they'll probably be putting together some whatever SASE SKUs and all the different capabilities that they can put in and bundle it as a SASE. This is a SASE product. But it's a framework. There's a bunch of different capabilities here. And no one vendor is going to really be doing it all for the time being. I just don't think so. So it's about understanding your requirements, understanding what's out there, and then getting people to prove it. And I think that if you're going with the framework that we've spoken about, that of the different capabilities that SASE should be delivering and why we're delivering it, connecting all the highly distributed users to your highly distributed workforce, to your cloud, your highly distributed set of applications, I think that it's going to be, and applying the security mechanisms to it, I think you're going to be on a good way to proving it and meeting those requirements. I think we'll close it for now. I think that's at time, but look, if anyone has any other questions, I'm sure you'll be able to get in touch. Thank you. Bye.